The other relationship is the relationship between force and velocity. So this is a relationship that exists between the force that a muscle fiber needs to produce in order to do work on an object, in order to move an object, and or the amount of active tension that that muscle fiber is producing, because those are the same things. In order to move that object, you produce active tension, which will then equal the object and therefore allow work to be done on the object. Or you could also call the x-axis the load of the object, because in order to move an object, you must equal what that object's load is and produce energy above and beyond that to do work on the load in order to allow for the muscle fibers to shorten in length. So it's the relationship between that force or load and the velocity with which the muscle fiber can then change the length of that load, or change the length of the muscle fiber to move the load. So on the y-axis, we have the velocity of the change in length, be it shortening or lengthening, and on the x-axis we have the tension or force or load that we're going to be moving. And this one's easier to understand, it's easier to conceptualize. At the basic level, the heavier the object, the slower the muscle fibers can move that object. Let's think about this in an example. If we have 10 myosin head groups, so 100, let's say 100, possible cross-bridge cycles. And it takes 90 cross-bridge cycles to equal a load. Let's say a box of books. If 90 cross-bridge cycles are required to equal the box of books, equal that load, we only have 10 cross-bridge cycles possible to actually move the load. Now contrast that to, let's say, a box of feathers, where it may only take 10 cross-bridge cycles to equal the load of the box of feathers. So we now have 90 cross-bridge cycles possible in order to move that box of feathers. If 90 are doing the work of the moving versus 10 doing the work of the moving, it's going to move a lot faster. Heavier the object, the slower the velocity of moving it. Up to a point where now we can produce the exact same amount of tension as the object. And if our maximal amount of tension is equal to the object, it's not going to move because we have no cross-bridge cycles available in order to move it. If it took all 100 cross-bridge cycles to equal a heavier box of books, we have no cross-bridge cycles possible in order to move that. And therefore, we would have an isometric contraction because you wouldn't be able to move that object. Now, if we allowed ourselves to move that object and to lengthen the muscles using gravity to move that object, the object could get even just a little bit heavier and we could still move it. And so that's this lengthening portion of the graph. You can lengthen to an extent, to a point where it just drops off, a heavier object than you can shorten your muscles with the aid of gravity, allowing for you to lengthen the muscles with that object. So a couple points on this graph. The first is at zero load, so where there's no load at all, you will have the maximum shortening velocity. And that's an intrinsic property for individual muscle fibers. However many cross-bridge cycles you have in series will determine how fast, maximally, that muscle can shorten, can have a concentric contraction, and just be contracting against nothing. When there's zero load, it's just air and gravity that you're contracting against. The other point is that at zero velocity is our minimum shortening velocity. That seems pretty understandable. But also, zero velocity means there's no change in the length. So if we have no change in length, by definition, that's an isometric contraction. And if we have all of the myosin head groups involved in cross-bridge cycles in order to simply equal that of the load, and if they're exactly equal to each other, that is our maximal amount of isometric tension that that muscle fiber can produce. And remember, from the last relationship, that is dependent upon the length of the muscle prior to the contraction being initiated, that the maximal amount of isometric tension can increase and decrease and increase over those variety of lengths. On the left side of the relationship, we have isotonic shortening and then isotonic lengthening on the right side of the relationship. And as the object gets more heavy, as the load gets greater, as the amount of tension or force that the muscle fiber must produce in order to work on that load, the shortening velocity will decrease, and we can surpass it, and then the lengthening velocity will increase to a certain degree, and then it will fall off.